started, I think, 180.
Oh my God, 148.
What? No.
Who can go lower?
Okay. 148.
94.
Yeah, 94.
94.
You're real one.
94.
94.
Okay, one more
I
time.
think I did 94. Wait, no, I didn't say 94.
It's because I'm not like you.
You guys see H?
94? Can anybody go lower than 94?
Alright,
Arr.
cool, congrats.
Okay, number 94. So I like to call these Chani boys. Carbon, hydrogen, oxygen, nitrogen, Chani. Oh, Chani boy. Like Chan, carbon, hydrogen. Yeah, anyways. 94, a compound contains only carbon, hydrogen, and nitrogen. So this is not a Chani boy, it's just a carbon, hydrogen, nitrogen. Combustion of 35 milligrams of the compound produces 33.5 grams of CO2 and 41.1 grams of H2O. What is the empirical formula of the compound? So the first thing to do is figure out your milligrams of each. So this is how I did it. Let me zoom in a little bit and show you what I did. So I took my, this is number what, 94?
Yes.
I took my 33.5 milligrams of CO2, and I know that there are 44.01, I don't know if you guys are going to like this, milligrams of CO2 in 1 millimole of CO2.
No. Dude.
Why not? It doesn't matter. All right? If you want to go to grams, that's fine. It just saves me a step. All right? And I know that for every 1 millimole of CO2, everyone always hates this, there is 1 millimole of carbon. I know, it's disgusting. And every 1 millimole of carbon is 12.01 milligrams of carbon. So that gives me 9.14 milligrams of carbon. I know you guys hate the milligrams. That's okay. Then I'm going to take my 41.1 milligrams of H2O, and you're eventually going to have this one memorized. There's 18.015 milligrams of H2O in 1 millimole of H2O. I know, disgusting. In 1 millimole, and if you guys want to convert to regular, you can. That's probably what you did. Of H2O has 2 millimoles of hydrogen. Watch out for the subscript. This is where people are going to make their mistake, because there's 2 hydrogen in this compound. You guys okay with that? Yes? And every 1 millimole of H has 1.008 milligrams of H. So that gives me 4.60 milligrams of hydrogen. They told me in the problem that, what are we numbering on? We're number 94. This makes 41 point, no, it says 35 point, there's 35 milligrams of the compound. So now I'm going to do percent comp. I'm going to take my 9.14 milligrams of carbon. I'm going to divide that by the 35.0 milligrams of the compound times 100. And I'm going to take my 4.60 milligrams of hydrogen and divide that by the 35.0 milligrams of the compound times 100. So this gives me 26.1% carbon. And the other one should, oh no, and then this one gives me 13.1% hydrogen. How am I going to get my percent nitrogen from that? Yeah, I'm just going to subtract. When you subtract, that ends up being 60.8% nitrogen. Now, all of my percents add up to 100, so I can assume how many grams?
100.
I'm going to assume 100 grams. So now, and you guys see how leaving it in the milligrams kind of saved me a step? See? Kind of saved me a step. All right? You got the same answer I did. If you change it to grams, it's fine. So I'm going to take my 26.1% and turn that into 26.1 grams of carbon. 13.1% into 13.1 grams of hydrogen. And I'm going to take my 60.8% emit that 60.8 grams of nitrogen times 12.011 grams of carbon in 1 mole of carbon times 1.008 grams of hydrogen in 1 mole of hydrogen times 14.007 grams of nitrogen in 1 mole of nitrogen. You're going to start memorizing these pretty quickly. So I got 2.17 moles here of carbon. Here I got 12 question.
Wouldn't it have to be like H2 or is that just like when it's like by itself?
So we're just dealing with hydrogen, all right, the atom. We're not really dealing with hydrogen, the molecule.
Okay.
So it'll just be H. Good question, though. Good question. And I got 4.34 moles of nitrogen. Divide by the smallest. So divide by 2.17, divide by 2.17, divide by 2.17. This gives you 1, this gives you 6, and this gives you 2. So the empirical formula is CH6N2. I can. So on that one, the only tricky part was you had to figure out your grams in the beginning. Or I did milligrams. Figure out your grams, divide it by the total, get your percent, and then you're ready to do your regular old empirical formula. That's fine. I can read it. Can you read it?
I'm not the best gauge for it, but
If you can read it, I can read it.
what? It has numbers. Yeah. They are there.
I bet I can read it.
Okay, so for like 101, why is there like AQ or like L? Or
So
S and something?
those are just states. So L is liquid, AQ, aqueous. We talked about that last year. We're going to talk about that a lot more next chapter.
So we didn't. It doesn't like really.
You
matter.
didn't?
No.
Or,
Rock just sort of.
he's just like, don't worry about it. He like mentioned it, and he was like, eh.
Okay. We'll talk about it next chapter. We'll talk about it next chapter.
Just like ignore it for now.
For now. Yeah. And the good thing is on the AP test, those states, they never actually grade for putting those on there. But it's going to be important for what we do next chapter. Net ionic equations. It's super fun. Super fun. Also something new. So that'll be something you've never seen before. Next question.
11.
I heard 101.
111.
111? Okay, 111.
Oh, okay, I don't care. It's not, I wasn't sure about it.
Wait. 111? I thought it was 117.
What's 111?
It can be whatever we
No,
want.
I don't need 111, sorry.
I want 20.
Maggie wants 111.
Wait, yeah.
Maggie wants 111.
I don't want to talk about it again.
Okay, on 111. Oh yeah, I love these. These are kind of fun. So on 111, I've got rocket boosters. And then I've got an equation. And then it says what mass of NH4ClO4 should be used for the fuel mixture for every kilogram of Al. So on this one, I'm just going to start with 1.00. It kind of depends how you want to set up your sig digs. I'm going to say 1.000 kilograms of aluminum. That's how I'm going to start with that. And I know that 1 kilogram of Al has 1,000 grams of Al. Now I'm going to go to moles, because moles are always the goal. And I know that there is 26.9, what is it? 82 grams of Al in 1 mole of Al. Now I'm going to Stoic step it. And in the problem, I have 3 moles of Al. And I'm trying to figure out what? NH4ClO4. That's a 3 to 3. Yeah. Is 3 moles of NH4ClO4. And every 1 mole of NH4ClO4 is 117.49 grams of NH4ClO4.
That Stoic stuff, if you didn't like write a balanced equation, you just know it.
It's in the book.
The
They gave you the balanced equation in the book on 111. Yeah. There she blows. So did they ask for this in grams or kilograms? They didn't really say.
It just said mass.
But I got 4,355 grams of NH4ClO4. 4,355 grams of NH4ClO4. Cool?
Correct.
Can we do 120, please?
No, 117.
117.
Both of them, guys. It's okay.
117. Okay. 117, we're looking at bacterial digestion, right? Yes?
Yeah.
Oh, yeah. There's a little bit of thinking you got to do at the end of this one. All right. On 117, I'm going to start out with what? How would you start that?
I started with the
I started by turning kilograms of wastewater into kilograms.
I would start with the waste. I would start with the kilograms of waste. So I'm going to start out with my 1.0 times 10 to the fourth kilograms of waste. And I know that in 117, they gave me a little, okay, so here's where you got to kind of figure this out. I know that for every 100 kilograms of waste, how many kilograms of NH4 would I have?
300.
No. 3.0 kilograms of NH4 plus. Do you understand why I just did
that's
this?
just 3%.
Because it's 3%.
Oh, so you just use 100 because it's...
Yes. So I assume 100 grams, and I make it 3%. What? Sure. So I assume 3%. That's kind of the thing you have to think through how to use that 3%. Now I've got kilograms. I know that for every 1 kilogram of NH4 plus, I'm going to have 1,000 grams of NH4 plus. And I know that there is 18.04 grams of NH4 plus. Ugh, getting sloppy. For every 1 mole of NH4 plus. Does the positive change my mass? No, that's just a different number of electrons. And then, is there a balanced equation they gave us on 117? Yeah, I'm going to Stoich step. There is 55 moles of NH4 plus for every, what are we trying to get this to? We're trying to get this to bacterial tissue, which is C5H7O2. For every 1 mole of C5H7O2. I should have just done BT instead of writing that out. And then 1 mole of this, right? 1 mole of C5H7O2 has a mass of 113.12. 113.12 grams. But that's not all.
What?
So you're going to solve there. So you're going to solve there, and I got 3.4 times 10 to the fourth grams of tissue. But on 117, it said, assume that 95% of ammonium ions are consumed by the bacteria. So I'm only going to get 95% of that.
So what? Yeah, you just take 95.
So I have to take this number times what? What? Times 0.95. So multiply this by 0.95, and then your real answer ends up being 3.2 times 10 to the fourth grams of BT, bacterial tissue. So on this one, you need to figure out the 3%. this step, and at the end, multiply by the 0.95. That was the tricky part of that. Everything else was just kind of regular stoic. Megan.
I, at the beginning, did 1.0 times 10 to the 4th kilograms of wastewater and multiplied that by 0.03 to get 300 kilograms
Okay.
of ammonium, and then I just did everything else exactly the same. Is that all right?
Also works.
Okay.
Yep. Multiple ways you can do that.
Right. So 120 is kind of the same to that?
Number 120.
I think
120 is going to be a little same, a little bit different. I kind of like doing 120. I'd love to work it out if you guys want me to.
Yes.
Okay. I kind of like doing 120. Yes. Because I have these narrowed down to the ones that I like to work out. So, because some of these I don't like working out. And also people have been asking me, what's the rigor of these questions compared to the test? The questions in the book are always harder than the test.
Oh.
So, questions in the book are always hard. I'm trying to over-prepare you. I try to over-prepare you on the book stuff, so the test should hopefully feel easy.
Oh, I thought you meant the AP test.
AP test is also like, they're not going to be asking you, they can't drill down this specific on just stoic, because they're testing you on 3 or 4 units at a time on one question. So it's going to be much broader. So the AP test is more like, can you remember what you've learned? Which will, it's fine. That's so far. So far. 120. 120. This one is so fun. I'm trying to figure out if I want to just, yeah, I'm going to do it like this. I'm going to do it like this. All right, because it's like the biggest line of stoic of all time. Yeah. Because you can do this all pretty much as one line of stoic. On 120, the first thing you have to do, the Space Shuttle environmental control systems handled by excess CO2 by reacting it with lithium hydroxide pellets to form lithium carbonate and water. What's the first thing you got to do here? Write an equation. Write an equation. So my balance equation is going to be LiOH plus CO2 yields Li2CO3 plus H2O. There's a fantasy show I watched about space. It's about these people that are on this spaceship that travel like really far deep into space, and I can't remember the name of it. Another world. It was on like Apple or Netflix or something. Another world? I don't know. But they're on this spaceship, and the CO2 scrubbers actually, like, they start to build up CO2. So they haven't like been on Earth in like years. So then the person on there is super smart, and they find lithium hydroxide pellets. Actually, they might have used sodium hydroxide, but it'd be the same thing. So they start dumping all of these into the ventilation system, and then it rains on the ship. It's really cool because you make water when you do that. So it cleaned the system, and it rained on the ship. And I was like, oh, I know the chemistry behind that. So kind of cool. Anyways, is this balanced? No. 2 here, and now it's balanced. Now we're ready to stoic. Before we stoic, there's one quick little thing I would figure out. I would figure out how many liters per minute do I actually need? How many astronauts are on the ship? I have 7 Astros. I'm trying to show my work, right? Times 20 liters, right? That they're consuming. So that's going to be 140 liters per minute. So there's my rate I'm going to save for later. There's my rate I'm going to save for later. What's that?
Isn't that air?
Yeah. Yep. So I'm going to start out with how many pellets of LiOH. I start out with 25,000 grams of LiOH. I'm going to take that directly to moles. There's 23.95 grams of LiOH in 1 mole of LiOH. Stoic step. There are 2 moles of LiOH for every 1 mole of CO2. I know that every 1 mole of CO2 weighs 44.009 grams of CO2. Here comes my first conversion. Here comes my first conversion from the problem. On 118, wait, no, what number are we on? 120? What percent is exhaled by air?
4%.
Only 4%. So that means for every 4 grams of CO2, right? I'm getting 4 grams of CO2 for every 100 grams of air. That's the first tricky part. 44.009. 44.009 grams of CO2. Does this make sense what I just did?
Yes.
It's only 4% CO2 for every 100 grams of air. So that's the first thing that you had to kind of think. And you'll get better at doing these percents as we work through them. Now I'm at air. I have a density of air, right? That they gave me, which is for every 0.0010 grams of air, I have 1 milliliter of air. And you can see how we're getting close to needing this. We're so close. We know that there is 1,000 milliliters of air in 1 liter of air. And then I know that I need 140 liters of air, right? For every 1 minute. But they didn't ask me for minutes. They asked me for what? They just said time, right? I feel like minutes isn't super helpful, so I solved it to hours. I solved it to hours. So that every 60 minutes is 1 hour. That is a massive line of stoic. It's a massive line of stoic. So here's a rate that I saved. I used that rate. This was the tricky part. Here's one rate they gave me. And then here was the other rate. So that was using 2 different rates in one line of stoic. Tricky part was getting the 4 grams of CO2 for 100 grams of air. You should end up getting 68 hours. 68 hours. Oh, what in the world? This thing just started moving. Okay, hold on. Did you guys see that? Did that freak you out? I think I pressed the button to make... Whoa, calm down. Calm down. Come over here. You can do it. A little lower. There we go. Okay. That was 120. It's kind of fun. Kind of fun. Next one.
148.
148.
Yeah.
What happened on that? Was 148?
We good with that?
That was 148.
We good with doing 148 next?
Yes.
Okay. 148. Okay. 148. Now we're into additional exercises. So you know this is where it gets fun. Terephthalic acid. Say that 3 times fast. Is an important chemical used in the manufacture of polyesters and plasticizers. It contains only carbon, hydrogen, and oxygen. So this is a Chani boy. Combustion of 19.81 milligrams of terephthalic acid produces 41.98 milligrams of CO2, 6.45 milligrams of H2O. 8.250 moles of terephthalic acid has a mass of 41.5 grams. Determine the molecular formula of terephthalic acid. So, on 148, this is going to start out similar to how we did the last one. I might also keep going this way now that I'm sideways. On 148, I have 41.98. I'm on the screen, right? Yes. Milligrams of CO2. I know that there is 44.009 milligrams of CO2 for every 1 millimole of CO2. Wait, hold on. For every 1 millimole of carbon. I want carbon. I don't want carbon dioxide. For every 1 millimole of carbon. Wait a second. What am I doing here?
Don't we go to CO2 and then CO2 to carbon?
I'm thinking here. There's 44.009 milligrams of CO2. No, this is fine. In every 1 millimole of carbon, in 1 millimole of carbon would be 12.011 milligrams of carbon. Yeah, that's good. We're good. So that's going to give me,
Directly gram CO2 to gram moles.
because,
Because?
oh,
You have carbon on top of it.
okay, 44.009 milligrams of CO2 in 1 mole of CO2. I kind of skipped a step, didn't I?
Oh.
Yeah.
I kind of skipped a step. But it's still going to be the same work. You know,
Okay.
let's just start over. All right, let's get it right. 41.98 milligrams of CO2. There is 44.009 milligrams of CO2 in 1 millimole of CO2. Every 1 millimole of CO2 has 1 millimole of carbon. This looks better, right? In 1 millimole of carbon is 12.011 milligrams of carbon. Does that look better? Probably. Yes? Okay. So that gives me 11.46 milligrams of carbon. 11.46 milligrams of carbon. Same thing for your water. I have 6.45 milligrams of H2O. There is 18.015 milligrams of H2O for every 1 millimole of H2O. And 1 millimole of H2O has how many millimoles of H? 2. 2 millimoles of H, and every 1 millimole of H is 1.008 milligrams of H, which should give you 0.722 milligrams of H. Divide those by the total. On 148, the total is 41.98. Wait, hold on. No, it's 19.81. So make sure you're dividing by the right thing, because it says there's 19.81 milligrams of terephthalic acid. So I'm going to divide this by 19.81 times 100, divide this by 19.81 times 100. You end up getting 57. We're doing 2 after the decimal for these, right? Yes? 57.85% carbon. You get 3.64% hydrogen. Subtract from 100 to get your oxygen, which I did that, and I got 38.51% oxygen. Now what? Assume 100 grams. Assume 100 grams, right? And then do your empirical formula. I have 57.85 grams of carbon times 12.011 grams of carbon in 1 mole of carbon. I have 3.64 grams of H times 1.008 grams of H in 1 mole of H. And finally, I have 38.51 grams of O times 15.999 grams of O in 1 mole of O. Moles of carbon, I got 4.817. Moles of hydrogen, I got 3.61. And moles of oxygen, I got 2.407. Moles carbon, moles hydrogen, moles oxygen. There's only 6 questions on the test tomorrow, by the way.
Okay, that's kind of.
They're gonna
I
be
don't like
like,
that.
they're gonna be a pain.
But think about it,
They're gonna be
right?
confused on the question.
Divide by the smallest. So I'm dividing by 2.407 divided by 2.407 divided by 2.407. When I do that, this one gives me 1. This one should give you 2, but this one gives me 1.5. So what do I have to do? Times 2, times 2, times 2, 4, 3, 2. So the empirical formula of terephthalic acid is C4H3O2. I don't think we're done yet, though.
What?
It also wants to know the molecular formula.
Oh.
So the way I do these, rough mass, 4 times 12 is 48, plus 3, plus 32. 48 plus 3 is 51. 51 plus 32 is 83.
Yeah.
So this is equal to approximately 83 grams. And on 148, they told me terephthalic acid has a mass of 41.5, right? What? Oh, for 0.25 moles. You're right. So there's a little conversion we have to do there. Good call. What? Yeah, just multiply by 4. So I'm going to take my 41.5 grams times 4. So that gives me the 166 grams. So 166, well, 83 times what gives me 166?
2.
Times 2. So I have to multiply all these by what?
2.
By 2. So the MF is C8H6O4. So here's my EF, and here's my MF. That was 148. Next one. 150. Can I turn the page?
Yeah.
Yes. 150 back to vertical. On 150, is this the EH1?
Yeah, the E3H8.
A binary compound between E and H contains 91.27 E, 8.73% H. The formula is E3H8. Calculate the atomic mass of E. So what am I going, let's write down what we have. I have E3H8. I have 91.72% E, and I've got 8.73% H. Also, this is my initials. That's why I picked this one. No comment, okay. You just like to show us the work. Assume 100 grams. Assume 100 grams. So, on this one, it wants to know the atomic mass of E. Okay, well, then let's figure out what we know. We know H, right? E's an unknown, yes?
Yes.
So I'm going to take, and I'm going to say that this is 8.73 grams of hydrogen, 8.73 grams of H. I'm assuming 100 grams here. And I know that there is 1.008 grams of H in 1 mole of H. In my empirical formula, I know that there are 8 moles of H, not 8 moles of 8 moles of H for every 3 moles of E. I can now solve and figure out how many moles of E I have. You cool with that? Yes? So this tells me that I have 3.25 moles of E. Now, keeping my assumed 100 grams, I'm going to take my 91.72 grams of E. I'm going to divide that by my 3.25 moles of E, and that's going to give me a molar mass, something grams per mole. That ends up giving me 28.01 grams per mole of E. What element is that? Silicon. Yep. So this is Si. Did you get the right answer?
I got 20.10.
28? Did you get the right answer? Then you're good.
I did a very different.
There's more than one way to do these.
Oh, it's about the same.
I said like the percent.
So, once again, assume 100 grams. Use what you know. We know hydrogen. All right? So start with what you know. Start with what you know. Next one.
How do you do 91.72?
How'd I get this? Because I assumed 100 grams.
Oh,
So if I assume 100 grams, right? These are my percents. That's where I got that. Next one.
173.
Wow, that was unanimous. 173.
this one was a problem.
No, it's good to work through these. Good to work through these. All right, 173. I just have Weezer in my head now. Like once you start listening to Weezer, you can't get it out of your head.
Pushing P.
No pushing AP.
Oh!
173. What'd you say?
I said we're really getting shocked.
Compound contains only carbon, hydrogen, nitrogen, and oxygen. Ah, the true Chani boy.
Johnny boy.
So this is actually a Chani boy. So I have 0.157 grams of the compound, produced 0.213 grams of CO2, 0.3010 of H2O, another experiment. We have 0.103 grams. Okay, so we have two different experiments running here. So let's start with experiment 1 with our 0.213 grams of CO2. So I have 0.213 grams of CO2. And we know that CO2, you guys had this memorized yet? 44.009 grams of CO2 and 1 mole of CO2. I don't want CO2 though. 1 mole of CO2 is 1 mole of carbon, and 1 mole of carbon is 12.011 grams of carbon. So, let's see. That gives me 0.0581 grams of carbon. Let's do the same for our, what's the other one? H2O, is that the next one?
There's H2 and there's ammonia.
Let's do H2O next. So I'm going to take my 0.0310 grams of H2O times 18.015 grams of H2O in 1 mole of H2O. In 1 mole of H2O, I have 2 moles of H. And every 1 mole of H is 1.008 grams of H. So we need to get our grams of H. So for my grams of H, I get a small number. 3.47 times 10 to the negative third. It's small, right? Grams of H. Or 0.00347 grams of H. That's going to be more helpful. We good so far?
Yes.
Now I have to go to that second experiment. In the second experiment, we have 0.0230 grams of NH3. I do not have NH3 memorized. 17.030 grams, thanks Megan, of NH3 in 1 mole of NH3. And I know that for every 1 mole of NH3, I have 1 mole of N. 1 mole of N, and 1 mole of N is 14.007 grams of N. So you end up getting 0.0189 grams of N. Now we're ready to do our percents. Here's the tricky thing. make sure you're dividing by the right one. So in the first experiment, what are we dividing by? By what number? .157. So I'm going to divide my carbon by 0.157 times 100. I'm going to divide my hydrogen by 0.157 times 100. But what am I going to divide by my nitrogen by? By 0.103. So make sure you're using the second experiment to divide your nitrogen by 0.103 grams times 100. And at this point, it's the same as all the other ones we've done. So this gives me for carbon, let's see, what did I get? 37.0% carbon. Yeah. 2, 1, whatever. I'm not going to take up points if we go 1 or 2. Hydrogen, I got 2.21% hydrogen. And for nitrogen, I got 18.30% N. Subtract all those, and then you'll figure out what? Oxygen. So oxygen ends up being 42.50%. Now you've got 4%, and what are you going to do? Assume 100 grams. Assume 100 grams. So I have 37.0 grams of carbon. I have 2.21 grams of hydrogen. I have 18.30 grams of nitrogen. And I have 42.50 grams of O. 12.011 grams of carbon. 1 mole of carbon. 1.008 grams of hydrogen. 1 mole of hydrogen. 14.007 grams of nitrogen, 1 mole of nitrogen, and 15.999 grams of O in 1 mole of O. So, is it close?
Yeah, it's like.
That's fine. So it's 3.08 moles of C, 2.19 moles of H. I know I'm probably going to have to divide here or multiply at the end because that's not going to be very nice. This is going to be 1.31 moles of N and 2.66 moles of O. Divide by the smallest. Divide by 1.31. Divide by 1.31. Divide by 1.31. Divide by 1.31. This is going to give me 2, I believe. This is going to give me 1. This is going to give me, what's the first one going to give me? Like 2.33, something like that. And this one should give me 1.67. What do I have to multiply all those by?
You can pretend it's 2.
You'd multiply them by 3. Multiply them all by 3. Times 3, times 3, times 3, times 3. So you end up getting 7, 5, 3, and 6. Were there any other ones that you wanted me to show that I should definitely work out next period? What? So I'll work out the last 2. I'll start with those next period.
Do you have the study guide?
They're up there. There's 3. I know, there's a couple repeats on the smaller sheets. So next period, I will start out with the last 2. I'll record that so you guys can see that if you guys want to go and watch those. Sound good? C7, H5, N3, O6. Did you guys hear me say I'll work out the last 2 next period? Okay.
Pushing people.